Afternoon, it's Bill here, and we're going to make a video today. I'll have to beg your indulgence. I'm using a bunch of new equipment here, so I'm not quite certain how everything's going to work out. Feel free to send comments. Um, I'm going to try and break this up into a bunch of pieces here. So this is piece number one. Oops, there we go. And I am going to call this power sets. And I think that this is going to be review for all of you from your discrete mathematics. Um, the reason we're covering this is these are going to pop up in our next section in our book. You may recall we've already talked about these things called DFAs, which are deterministic finite state automatons. And the next thing we're going to talk about are these things called NFAs, lots of acronyms here. A non-deterministic, the N here stands for non-deterministic. Non-deterministic. It's a $3 word. You don't need to know what it is yet. Right now you just need to know what a power set is. Now maybe a long time ago you learned if you had a set S and it was equal to 1, 2, 3, maybe you learned about something. It could have been written several ways. I've seen it written this way, script P of S, and I've also seen it written this way, power of S, and I've also seen it written this way, 2 raised to the S power. I've also seen it written this way, 2 raised to this. Now remember, when we're talking about sets like this, if we were to come over here and put absolute values around the S, that's asking how many elements are in this set. So in this case, we would say 3. These all mean the same thing here. The reason why I bring it up is your author uses this notation over here. So I want to be consistent with your author and just explain what this means. And this is equal to the set of all subsets. And the reason why this notation comes up over here, where we say 2 to the S or 2 to the absolute value of S, in this situation you could put a 3 over here, because it would turn out, if I were to ask you how big is P of S, which is another way of saying what is this equal to, or how many elements are there in the power set of S. In this situation here, it would be 2 to however big S is, which is equal to 2 to the third, which is equal to 8. And again, if I were to come over here and say, well, what are the set of all subsets? Well, one subset of this would be just this. And then another subset would be this. And then another subset would be this. And then there are all of the subsets that have 2 elements in them. Like that. There is the subset that actually contains all the elements. And then there's the empty set. And it turns out the empty set is a subset of any set. And if you come over here and I count these 1, 2, 3, 4, 5, 6, 7, there were 8 of these. So the power set is actually this set right here. Like that. And that's the end of part 1. I hope that was clear, and we will move on to part 2 shortly.